Hey there everyone, welcome to Bright Engineering. Today we are going to look at a theorem under circuit analysis, which is the mesh analysis, right? So under mesh analysis, we are interested in the voltages that's across every particular element we have in there, right? But then interestingly, we assign currents to it. So the first thing that you should take notes is the number of closed loop we have in there. So with this particular question, we have 3 different closed loops, right? So you can consider this to be 1, this to be 2, and then this to be 3, right? And then when you have closed loop 2, we know that the same amount of current is going to flow through that particular loop, right? That's why we assign currents to it. So here we are going to assign our currents to it. So here is going to give us I1, this is going to be our I2, and then this is going to be our I3, right? But then the question is, why is it that we are assigning current to it, but then we are interested in the voltages instead? The reason for that is because from KVL, our Kirchhoff voltage law, we know that the algebraic sum of voltages in a closed loop sums up to 0, right? So it means that we are assigning current, the same amount of current is going to flow through it, but then the algebraic sum of these voltages should give us 0. So with the help of our current, now we can find the voltage drops across each resistor, right? So now let's kickstart. So taking into consideration loop 1, like I said earlier, we have 100 volts here minus 20, right? So this is a current producing element, this is also a current producing element, and when you have to go through it using your current, means that this 100 volts is going to produce current this way, right? But then when it gets here, it's going to enter this 20, but then ideally, because of this longest bar we have here, this 20 volts is also going to produce current this way, right? So it means that the current producing of this and this are opposites, right? So then we subtract the lowest from the highest. So now we have 100 minus 20 is equal to the number of voltage drops that we have in there, right? Which is going to sum up to 0. So when we take the 60, the only current passing through the 60 ohms is the I1, right? Plus 30, which is I1 minus I3. Right. The reason why we are subtracting I3 from I1 is because this I3 is also opposing the flow of this I1, right? I1 is going this way, I3 is coming this way, and we subtracted this from that because now we are considering this loop, right, which ultimately is for the I1, right? So we are subtracting any other current from the I1 whenever we are considering this loop, right? So plus 50 bracket I1 minus I2, the same analogy we use for the I3, right? I1 comes here, I2 is going here, so we have to subtract. Now we can expand, so we are getting 60 I1 plus 30 I1 minus 30 I3 plus 50 I1 minus 50 I2. We are getting 80 is equal to 60 plus 30 plus 50, right? Which is going to give us 140 I1. I2 is minus 50. And then I3 is minus 30, right? So we can leave it like this, or we can just divide all the sides by 10 to get 8, 14, minus 5, and then minus 3, right? So we know that this is for our loop 1. And then we are done, so our equation 1. Now let's go to loop 2. So for loop 2, we have 2 voltage sources. This 50 will be producing current this way. This 20 will also be producing current this way. So the production of current based on these two is taking the same route or the same direction. So instead of subtracting these two, we can now add it because they are not opposing each other. They are going in the same way. So here we are getting 50 plus 20 is equal to 50 into bracket I2 minus I1. Like I said when we were doing with the loop 1, now we are considering this particular loop. So any current, any other current would be subtracted from the I2 instead. That's only if they are opposing. Assuming that if I1's direction was this way, and then I2 is also this way, we would have added the currents because they are all flowing in the same direction. But then once they oppose this, you have to subtract the other current from the one you are considering, right? Good. So here we have plus 40 to bracket I2 minus I3 because I2 goes this way, I3 comes this way, plus 10 I2 because it's going to be the only current that flows through the 10 ohms, right? So 70 is equal to 50 I2 minus 50i1 plus 40i2 minus 40i3 plus 10i2. All right, so we're getting 70i1 is minus 50i1 plus we have 50, 40, and then 10. So we have plus 100i2 and then minus 40i3, right? So this would be our equation 2. And now loop 3. When we consider this loop, now we don't have any voltage source here, any current producing elements here. So it means that what we are going to get is the sum of these voltage drops is going to give us 0, right? So we are getting 0 is equal to here 30 I3 minus I1 plus 20 I3 because that's the only current passing through the 20 ohms, and similarly 40 I3 minus I2, right? So we are getting 0 is equal to 30 I3 minus 30 I1 plus 20 I3 plus 40 I3 minus 40 I2. So just grouping it like we did with the first two, we have 0 is equal to minus 30 I1 minus 40 I2 and then plus 30, 20, and then 40, so plus 90 I3, right? So this is also our equation 3. So we can just punch these 3 equations into our calculator, and then straight away we get the current for all these 3, right? So when we punch it into our calculator, we are getting I1 to be equal to 1.64 amps, I2 is equal to 2.12 amps, and I3 is equal to 1.49 amps, right? So with this, if we are being asked any question, like for instance, what is the current that passes through this 10 ohms, right? We know that the current that passes through this 10 ohms is just the I2. So straight away, our answer is I2, right? Which is going to be 2.12 amps. If you are being asked the current that passes through this 50 ohms, we know that the current that's passing through this 50 ohms is the difference between this I1 and then I2, right? So now you can choose to subtract any other from it, because when you are considering this loop, it is I1 minus I2, and when you are considering this loop, it's I2 minus I1. But then when you come down here, you look at the current that is greater, and then you subtract the least from it, right? So in this instance, it's going to be 2.12 minus this 1.64, right? If someone chooses this first loop and decide to subtract this from this, like 1.64 minus 2.12, the only thing that you're going to get is to get a negative answer, and the negative is telling you that the direction is wrong, but then it has to be the other way around, right? That means that we have to subtract this I1 from this I2 instead, right? Thank you very much for following. If this video has been helpful, don't forget to share, subscribe, and then comment.